Alright folks, last one, worksheet review. We're done. We're on the last, down the home stretch. Right. Determine the percent composition of copper sulfate. Copper 2 sulfate. So, copper, I look up copper and it is 63.546. Straight off the periodic table. Sulfur is 32.066 grams per mole. And oxygen is 15.999 grams per mole, but there are 4 of them, so that's going to give me 63.996 grams. Alright, I add those 3 up, and I come up with 159.608 grams per mole. Right, so what do? Well, I take the copper, and I take the 63.546, I divide by the total, which is 159.608. This is coming back to you. I'll multiply by 100%, and that gives me my percent composition, which is 39.8%. Right. And do the same thing for sulfur. Sulfur is 32.066, and I have to divide it by 159.608, multiply by 100%. Right, and that is going to give me 20.1%, which means everything else should be oxygen, which is 63.996 divided by 159.608. Multiplied by 100%, and that gives me 40.1%. So I'm right there at 100%, which is great. Right. Number 2 is determining an empirical formula of a sample. So remember, what we do is we change our percentages to grams. That's the first thing we do. So we have sodium, and it's 21.6%. So we're going to treat that like grams, and we're going to convert from grams to moles of Na, and that's 22.99 in 1 mole. And let's try chlorine, which is 33.3 grams, and we're going into 1 mole. We're converting from 35.453 grams into 1 mole. And our last one is oxygen. And oxygen is 45.1 grams, which we are going to divide by 15.999 grams per mole. Per mole down there. That's 1 mole. Okay? So, if I multiply them out, I get 0.940. I get 0.939. That's clearly a 1-to-1 relationship. And I get 2.82. Right. Well, I'm going to divide both of these by 939. 939, that's going to equal 1, that's going to equal 1, and divide by 0.939, and that's going to give me 3. Alright, so I have a 1-to-1 to 3 relationship, so I've got Na, and O3. That is my empirical formula. Alright. Let's do this one, the last one. This is our molecular formula for the following. So we're given nitrogen, oxygen, or given the molecular weight. So if we have nitrogen at 30.4 grams, we're going to convert it from grams, 15.007 grams, into 1 mole. And that number is going to happen to be 2.17. And if I take oxygen, do the same thing. That's 69.6 grams. And I'm going into 1 mole, and that's 15.999 grams in 1 mole. When I divide that out, I get 4.35. I divide by the smallest number. That gives me 2. The top one gives me 1. So my empirical formula is going to be 1 nitrogen and 2 oxygens. Oh, now how much does this thing weigh? Well, I've got 14 plus I got 32, because I got 2 oxygens, so that's 46. And 46 sure looks like half of 92. So that means I have to double everything. So my molecular formula is going to be twice NO2, so it's going to be N2O4. All right, that is it, folks. Hope that helps. If you have questions, please see us in class. We'll do what we can to help. All right, see you then. Bye-bye.